and regular bacteria.
So it's funny, as I look at my note card, I realize I left out something that I probably should have included. So I'm gonna call an audible here and add in an example or two before we get started. I don't know why I thought that that would be okay to do. So when you add and subtract rational expressions, you just have to know how to add and subtract fractions. And we'll probably at some point have a fundamental conversation about what it means to actually add and subtract fractions. Like if I gave you guys two fractions, if one had a bottom of 6 and one had a bottom of 8, what would their common denominator be? 24. And there's a reason for that maybe no one's ever explained to you. And I think that today's a good day to maybe get in and look at that, because the real like DNA kind of behind the scenes stuff that makes 24 the common denominator actually comes into play today. But anyways, I thought I would just bring this up. I realized that I shouldn't just assume that you would know this. So let's say we had like x plus 2 over 2x plus x plus 10 over 2x. You guys know this from back in the grade school days, that to add and subtract fractions, what has to be true?
The denominators.
The denominators have to be the same. And we gave exactly zero craps about that before break. Like with multiplying and dividing, it doesn't matter. You factor and you cancel stuff out. But to do plus and minus, you have to have the bottoms the same. And I looked at my note card and realized I didn't have any just warm-ups that address this. So you'll see that like in this case, the bottoms are already the same. So when the bottoms are the same, then we know that the answer is going to have that as its bottom, right? You don't add the bottoms together. When you have fractions with the same bottoms and you add them, you just add the tops and keep the bottom the same. And so what would the top be in this case? It would be, so I would do the x plus the other x, which is 2x. And then I would do the plus 2 and the plus 10 to make plus 12, right? And then we would simplify. And what you don't want to do is something criminal like cancel out the 2x's, because the 2x is part of a sum. 2x plus 12 renders him off limits. But what you could do is you could pull out a 2.
Yeah.
You could like literally triangularly divide everything by 2. But maybe a cleaner way to say that is to take the top and factor out the 2 and leave it as 2 times x plus 6 over 2x. And I'm just going to change colors on the bottom one just so that you can identify now. Those yellow things are now called factors, right? Mm-hmm. And factors cancel. So the 2's could cancel, and we would be left with x plus 6 over x. And again, you could have accomplished that back here if you did like some Dorito division, like that guacamole Dorito. If you can triangularly divide everybody, that's legal as well. Divide them all by 2, just right there, and you're good to go. So if the bottoms are the same, we proceed. If the bottoms are not the same, we don't proceed. And then there's one more thing I feel like I should say, and then we'll press into the actual scripted problems that I wrote here. So let's say we had 3x squared minus 4x over, I don't know, x plus 2 minus x squared minus 3x plus 2 all over x plus 2. Curious to see how you handle something like this. It's not a skill that's outside of your set. It's just easily overlooked. So bottoms are the same. So we're still kind of in that mindset of don't worry about the bottom. What's the top going to be? This is not like a factoring thing. This is not like a trick question. I'm just really after some fundamentals here.
2x squared.
Okay, I like the 2x squared. And for the record, that answer is correct 100% of the time. No one ever misses that. Ever. It's the next part.
Plus 3x. Plus 3x. Minus x.
Minus x is correct.
Oh,
and then the last part.
Minus 3.
Good job. So I just want to make sure that you guys are all fundamentally on board before we get started here, that this minus that I'm circling in red applies to everybody who comes after him, right? You don't see parentheses, but they're implied. If a minus attacks a fraction, then he says, I'm going all in, right? I'm not just going to like cherry pick and just make you a negative. He says, I'm going to make you negative x squared. I'm going to make you plus 3x, and I'm going to make you minus 2. Are we all clear on that? Okay. Okay, so again, if the bottoms are the same, proceed. If the bottoms aren't the same, then that's why today's lesson exists. So, all right, let's get to the first actual problem that I wrote. You're going to want to really pay attention and be sharp here today. The idea is to expose the greatest common factor. And I said that the wrong way, the least common multiple of the bottoms. And I think the best way to do that is to factor the dickens out of everything. And so I'm going to begin, don't worry about the tops. We should always focus on the bottoms first. So I'm going to focus on this lower right-hand corner. And instead of calling it 2x minus 10, I'm going to call it 2 times x minus 5. Factoring denominators is going to carry you a long ways for the next couple of weeks. So the question now becomes, this is never an easy jump to make, but we got to just do it. What would be the common denominator of 4 and 2 times x minus 5? This maybe is the appropriate time to talk about something that you learned back in grade school. And it's the grade schooliness of it isn't meant to imply that it's a little kiddie concept. It's just a fundamental concept that comes into play maybe today. So let's say that I had 3/8 and I was going to subtract from it 5/6. You've always known, because I asked you this earlier, that like you don't even think. If I give you this problem, you know right away to change both bottoms into 24s, because you just know from hanging out and doing stuff like this that's the number that they can both turn into. The question is why. And so in order to answer that, what we need to look at is like the DNA of the numbers. 8 in its purely stripped down, what we call a prime factorization, is 2 times 2 times 2. And what is 6? It is 2 times 3. So if no one ever taught this to you, let me be the first to teach this to you, that a least common multiple is the smallest number in the world that covers both denominators, if you will. So let's talk about this. So let's say I have a little box over here. And if you've heard this lesson before, then you heard me probably refer to it as like a little bag of Lego pieces, which if you've never heard this, you have no idea what I'm talking about. But let's think about that box right there. And what I want to do is I want to put prime factors into that box that will allow Gabe to build that. Only the thing I circled in yellow. If Gabe is going to build a 2 times 2 times 2, what does he need to have in the box?
There's 3 twos.
He needs to have a 2 and a 2 and a 2. Correct? You can't say he can only have 1 2, right? Like he needs 3 of them to assemble something called 2 times 2 times 2. So that is non-negotiable, is that Gabe needs to be able to build his. And then Gabe builds it, flexes, and puts his pieces back in the box, and then he hands it to Brenna and says, Brenna, build this. Can she?
No,
Why not?
3.
She needs a 3. She doesn't need all those 2s, but Gabe did. You don't get to pull them out because she doesn't want them. You have to have enough pieces and the correct pieces in the box so that everyone can build their thing. So if Gabe's going to build his, he needs 2 2 2. If Brenna's going to build hers, she just needs one of the 2s, but she needs a 3, correct? Therein, at its core, is the fundamental idea behind what you knew as a fourth grader as a least common denominator. It's at a greater level called a least common multiple, is what it is, right? And that's where the number 24 comes from, is you think about now all the pieces that were required for Gabe to build his and Brenna to build hers. I need a 2 and a 2 and a 2 and a 3. And 2 times 2 times 2 is 8, and 8 times 3 is, as we said, 24. So we're going to apply that same thinking to algebraic expressions. We need to think about the DNA of these expressions. So having said that, let us make let's factor the 4, by the way. This might sound completely crazy to you, but let's factor this 4 down into 2 times 2. And eventually, like, we probably won't do that, but maybe for this introductory problem, it might help us. This is as stripped down as I can make this problem now, by the way. That is as factored down as I can get the bottoms to be. So I'm going to make a box over here. This will be our little piece box. And again, the thing is, I have to be able to make a box that if I hand it to Sutter, he can build the red one. And then he puts his pieces back in and hands it to Christian, and Christian has to be able to build the green one, correct? So first off, what does Sutter need? He needs a pair of 2s. It's non-negotiable. He needs those to build his. And then he packages them back up, he puts them in the box, and he hands it off to Christian. And Christian says, this isn't enough. I can't build mine. What does Christian need? He needs an x minus 5. So maybe it's like overkill to think about the dumb little box, but I mean, it's not an easy concept to get across to people, this idea of a least common multiple or a least common denominator. You need every piece that everyone would need to build every denominator at different times. So what is the LCD? 4 times x minus 5. So we're going to write that down over here off to the side. We're going to say the least common denominator is 4 times x minus 5. And now, just like a little kid would do if they were learning about simple number fractions, is we just say, how can I make the bottoms be what I want them to be? Well, in the first fraction, the one with the red bottom, what's his bottom missing? So I'm going to take the bottom of that fraction and multiply it by x minus 5, but I'm also going to take the top and multiply it by x minus 5. Can I do that?
Yeah.
Yeah, I mean, really, what did I just multiply by?
X minus 5.
What is the yellow equal?
1.
1. I can do that. It's totally legal. I can multiply by anything I want, provided that I do it on the top and the bottom the same, because it just equals 1 and it doesn't matter at the end of the day. And then let's look at the second fraction. What's his bottom missing?
2.
He's missing a 2. You got to think about the LCD in that box. Maybe I shouldn't have erased the box. The box is the key. I need all those pieces. Who am I missing? Each fraction is missing a piece or more than one piece. What's that? He's missing the second 2. So anything I have written in yellow is stuff I've had to multiply in to make the bottoms both be what I want them to be. So at this point in time, help me with my math. Purple box. What does the purple box equal?
3x squared minus 15x.
Beautiful. What does the red box equal?
2x.
Nice. And what will the bottom equal?
4x minus 5.
4 times x minus 5. And again, if you call it 4x minus 20, I've heard Zach say that twice. I've got absolutely no issues with that. If you want to multiply it back out, feel free. Okay. I personally like to leave things factored. In the event that there's an opportunity to cancel something out, I'd like to have everything out in the open so that maybe that will present itself to me. And now it's just time to clean. What is my top going to be?
3x squared minus 13x plus 4. Plus 1.
Could we just look right at this and say we're done? No, I see a shaking head, and that's sage thinking. No, I will say most of the time, honestly, you're going to be done. But there is a chance that the top could factor. And if the top factors, and maybe, just maybe, one of the factors is like x minus 5, then I would be a fool to think that it wasn't even a possibility. And it does so happen in this case. I didn't mean for this to happen, honestly. This was just blind luck. But the top does factor into 3x and 1x and minus 1 and 4. So this was just a little, honestly, a little bonus. But do I care? I don't. I'm wise to do my due diligence and check. And if it can be factored, I should factor, but I want to make sure here that none of the factors match. It would have been pretty amazingly cool if one of them matched. But so if you were to leave the answer like this, you would be correct. If you were to turn it in and leave it like this, you would also be correct. I would feel more proud of maybe the person that did it the second way, just because then I could see that this person is really they're here to win. Like I see that you tried to factor, even though it didn't give us any fruit. Okay.
Brownie points for factoring.
Yeah, it's nice to see that, hey, I'm in it to win it. Like, see ya, hockey.
He did not say awesome thing. Wrong service. See you. That's Anderson. Yeah.
The hurdle for me every year that this topic comes up in this class is how can I get everyone to understand what an LCD is? That's my Mount Everest for this unit. So factor. That's what I mean, once you get good at this, you realize that this is kind of silly to do. But if I factor this lower right-hand denominator, I can pull out a 2x and it's left as x minus 1. How many pieces would I need in my box to make this buildable? First thing I obviously need in the box is a 5, right?
Yeah.
The second thing I need is a 2. I also need an x, and I also need an x minus 1. So if you think about it, like if I put just the 5 in the box, then Gabe could build the first one. And if I just put the 2 in the x and the x minus 1, then Irene could build the second one. But in order, again, for us to play the game where everyone has to be able to build out of the same box, I need basically everything. There is no overlap with these two denominators at all, right? But the first job is to figure out the box, the LCD. And once I know what the LCD is, it becomes a very simple and very repetitive question of what are the bottoms missing? So let's play the game. I'm going to move this one up into position, and we're just going to keep asking the same question cycle over and over again. What is the bottom of the first fraction missing?
The 2 and 2x. Okay.
It's missing
The
the 2x and the x minus 1. So we do it on the bottom and we do it on the top. For the record, I don't usually, you'll notice that after a while, probably even in today's lesson, I'm going to stop showing it on the bottom because like I already know where I'm going on the bottom. I usually just show it on the top because the bottom's like predictable. Right? What's the point? What's missing from the bottom of the second fraction? Just the 5. And I already know this.
Well, there is sign-ups for concessions this week for Thursday, Friday, and Saturday.
Give me just a minute and then you guys could do that if you want to. But I'm going to build the bottom real quick. So my bottom is going to be 10. Oopsie, I forgot to switch tools again. 10x times x minus 1. Just get that out of the way right now. Do you have any questions about that? Now let's clean the top. What is the answer to this little red dumpster fire going on up here in the corner? What is just that part equal?
2x squared. I guess 2x.
And then if I distribute the 7 through that, right? Then I get 14x squared minus 14x, right?
Yes.
Got it? And then the minus is going to apply to the 15. Okay. And I can tell you, I don't think this one's going to be factorable at all. So we'll just save the time on this one and just call it good. All right. Maybe not the best example to set, but I don't think this one's factoring down. Does anyone know what 14 times negative 15 is? Negative 210. Are there numbers that multiply to make negative 210 and add to make negative 14? It's 10, 21, 8, 7.
6 or 7.
Nah, it ain't gonna work. So I think we're done. Okay. Let's go to the next one. This one. 2x. These are usually the ones that I don't know why they cause headaches. Always a fun conversation. Without me drawing the box, anyone want to throw it out there? My little dumb box of pieces. What is the least common denominator?
X. And 2. Yeah. Wait, no, 2 and 2. You just have to multiply the 2 denominators.
You do. What we have to understand is that in this topic will really get beat to death here in the next few days, is that x and 4 are not separate entities. They are a thing. And x minus 2 is a thing. This x does not cover for both of them. I need a piece called x minus 4. And I need a piece called x minus 2. And despite my best efforts, you'd think 30 years into this, I'd have this down pat. I have no idea how to say that the right way. X minus 4 and x minus 2 are in no way related to each other. They are disjointed separate factors. And like Sutter said, I effectively wind up having to multiply them by each other. So tempting to think that they have some overlap and that somehow like the 4 can cover for the 2. This x minus 4 over in this thing and this x minus 2, they have no relation to each other at all. That's tough. Having said that, what is the first fraction missing? What's his bottom missing?
X minus 2.
He doesn't have the x minus 2. So I'm going to multiply. And do note, I'm not doing it on the bottom. Look at me. I'm third example and I'm already going rogue because I know what the bottom's going to be. So the next fraction, what's his bottom missing? So I'm going to multiply his top by x minus 4. I'm doing the bottom as well. Okay. Got it? Dope. I already know going into this. That's what my bottom looks like. Foregone conclusion. I would not multiply it out. There's no benefit to you writing x squared minus 6x plus 8, because then you might just have to turn around later and refactor it down. So just leave well enough alone. Call it good. Now, the top is just a basic skills test. And I would say that about 8 times out of 10, this gets messed up. So you've been warned. It's not the first part. The first part is silly. This little dumb purple thing over here. I don't think in 30 years I've had like 9 kids miss this. That's not what I'm talking about. So let's get the purple part out of the way first. That's just going to be 2x squared minus 4x. Easy peasy. It's this green beast that rears its ugly head year in and year out. And the reason for this is because it's a multi-step process. So what you don't want to do is think about the negative yet. What you want to do is take the white and the yellow things and multiply them together. Is that what you're going to say? Let's do that. What would that be if I multiplied the white and the yellow together first? X, don't give me a negative yet. I don't want the negative. Forget him. Just x squared
X squared
minus 2x. Good. It's imperative that you see it that way first and then negate it all because there's a minus in front of the fraction. And like I said 15 minutes ago, a minus in front goes and just flushes all the way through, right? So we're going to wind up with 2x squared minus 4x minus x squared plus 2x and plus 8. That's a lot if you don't respect it. Respect it. Do the multiplication and then the distribution. Let's clean it up and see what happens. Who knows? So if I put all that junk together on top, I get 1x squared minus 2x plus 8 all over x minus 4 times x minus 2. The only chance I have of this problem not being done is if I can factor the yellow thing. And of course, there's no way that's happening. You've been hanging out with me for too long to even consider that. right? We know that they would both have to be negatives, and there's no way that that's happening. Now, if that 8 were a minus, then I could do this, but that plus is no deal breaker, right? Okay. You guys still with me? All right.
Ooh.
What I did when I wrote these examples was I tried to look at your assignment and think, can I cover every possible scenario that would make them on this assignment say, wait, we didn't do one like this. So there. I got to get cooking. What do we do first? It's my third favorite F word. What is it? Factor. Very good. So I'm going to take this lower left-hand corner and I'm going to factor it by pulling out a 2.
What's your first thing?
Oh, you know what it is.
What's your second?
Fire truck. Which is neat because now I can see that how many pieces are required to go in the box? 2. One of them is called 2, and the other one is called 2x minus 5. So I know now that my least common denominator is 2 times 2x minus 5. So I just fundamentally go through and ask the same question, rinse and repeat. What does the first fraction's bottom need? Nothing. So he just stays the same. What does the second fraction's bottom need?
The 2.
So I'm going to add, not add, I'm going to place in a multiplier of 2. Whatever the bottom needs, you give it to the top. Whatever the bottom needs, you give it to the top over and over again. And I already know what the bottom looks like. I'm just going to just put it in here. Ooh, why did I get yellow? I didn't want yellow. That's creepy. There we go. What is the bottom going to be?
The 2 times, well, 2.
All right, so here we go. Basic skills test. Let's never, ever fail this test. Not at this level, okay? We failed this test when we're younger, but now we just don't fall for this garbage. What is the answer to that purple, yellow, white mess going to be? Minus 2x plus 2.
And then you get
It happens in a hurry if you mess it up. And then I can clean up the 5x and the minus 2x because they're like terms, right? So I could just call this 3x plus 2. And again, fourth verse, same as the first. If I have any chance of this going further, it would be that something could factor to produce something that looks the same as something else. And that's just not happening. The top is dead. So that one is totally dead. These last few, I hope, go quicker, but we shall see. Sorry. Tomorrow, obviously, I'll give you a work day. You think after this long, I know how long every lesson's going to take, but no. I wanted to make sure I threw some in like this because it's not always about like factoring and pluses and minuses and things like that. Sometimes it's easier. Can anyone just look at it and just real quick, boom, tell me what is the least common denominator? What number do I need to cover the 2 and the 5? So it's going to be a 10. How many x's do I need to make sure that both parties can accomplish their goal? 2. So I have 10x squared. And how many y's do I need in total to make sure that both parties can accomplish their goal? So there is your least common denominator, 10x squared y. And we're just going to cook through it and just say, what does each bottom need? Whatever the bottom needs. Sorry, Christian. I'm trying to get... You okay? You want a break? Okay. Spend forever. I'm sorry. Whatever the bottom needs, I give to the top. The first fraction, what's his bottom missing? He's missing a 5 and one of the x's. Good job. Second fraction, what's his bottom missing? He's missing a 2 and a y. So we're going to wind up with, well, let's get this out of the way first. We already know what the bottom is. The bottom is 10x squared y. What's the top?
15 minus 8.
Done.
Ding, 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 ding. Who messed up my stuff?
This next problem I wrote with one very specific thought. It was not to confuse people. It was just to make sure that if you're inclined to fall into this trap, that you
Get out.
that we do something today to avoid that in the future. It's not coincidence that there are 3 X's on the bottoms. So anyone know what the least common denominator is?
6.
Wouldn't it be nice if it was just 3x minus 6? And then you could say that this 3x that I'm underlining is like, I'm awesome because I cover that 3x and I cover that 3x, right? Wouldn't this be rad? No, it doesn't. It doesn't work that way, does it?
U squared.
This is probably a good problem for us to go back to factoring. So let's take the one on the left and let's get it stripped all the way down. So if we pull out a 3, then we're left with 3 times x minus 2. Right?
Mm.
And then the one on the right is just a 3 times an x. So I don't really feel like I need to do much for that. So if I go back and use my silly little box analogy thing, the Lego bag, whatever, what needs to go in the box or the bag? What do I need? I need a dang 3. Because the 3 will cover the one on the left, because I got 3 times the thing. And the 3 will cover the one on the right, because I got 3 times the thing. And I only need 1 3. It covers them both. What else do I need?
An X.
I need an x minus 2.
And an X.
And I also need an extra x. Isn't that crazy? Again, those 3 x's don't cover each other because one of them is part of 3x minus 6. He's not a free factor thing. He's part of something else. So overall, to clean this up, we could say that the least common denominator is 3x times x minus 2. And now we go through and just ask ourselves the question of what does the bottom need? Because whatever the answer to that is what I'll give to the top. So for the first fraction, what's his bottom lacking? He's missing the x.
Yeah.
He's like, I don't have that extra x there, so I'm going to take that and I'm going to multiply it on the top and the bottom. Second fraction, what's his bottom missing?
An X plus
He's
2.
missing the x minus 2, so I will give it to the top and the bottom. Look at me showing it on the top and the bottom. Whoop. And then I will build the bottom because I already know what the bottom is going to look like. The bottom is predictably going to be 3x times x minus 2. The assignment that I give you Wednesday will be more fun than the one that's like today/tomorrow. Tomorrow is kind of like more of a, it's kind of more lame. The next one has more fun stuff that happens. But anyways, let's finish the top. What's purple egg? Nice. And then what's answer to red egg?
Negative X plus 10.
Nice. And then, of course, we always want to simplify completely. So we're going to get negative x plus 10 over 3x times x minus 2.
That's all.
Got it?
That's G.
Uno mas. And by this point in the lesson, this last example will not cause you any troubles at all. So you're going to just kill this one. I did want to put this one up here to see if anyone would ask the burning question. And by the way, the ability to do this has not yet presented itself. So I'm just going to see if any of you little wizards ask the questions.
That's not much. But
Yeah, there it is. Are we allowed to simplify before we even start?
sure.
Sure. So if you see problems like this where this is a possibility, the answer is, oh yeah. And actually, this does present itself quite a bit on the computer-generated worksheet that we're going to get today and work on tomorrow. So watch out for this. If you see an opportunity to make a fraction cleaner before you begin the process, take it. So it's not a lot, but I do notice that this first fraction right here, what can I pull out of the top and the bottom?
X.
I could drop them both down by x, which is in the end really maybe not that big of a deal, but it will make my life a little bit easier. So if I take this x off the top, and I take one of the X's off the bottom, and there'll be sometimes be way more than that you can do before you start. But the answer is, oh yeah, please feel free to clean before you start. It won't hurt you if you don't. It just helps. All right, let's get to it. What is the least common denominator?
15x.
15 is necessary to cover a 5 and a 3. And how many X's are needed to cover both parts?
3.
3 of them. So your least common denominator is 15x cubed. And for the 7th time, I will ask the question of what does the bottom need? We just keep doing it. Technically, it's like the 13th time I've asked this question. What does the bottom of the first fraction need? So we give the top a 3. Second fraction, what does the bottom need? It needs 5 and x cubed. So we'll give it to the top. And we already know what the bottom's going to look like. The bottom is going to be 15x cubed. What's the top going to be? Is there any benefit to factoring that top egg? I could pull a 2 out of it, but we're all smart enough in this room to know that that's really not going to bear any fruit. Right. So that could be an acceptable answer. Would you guys want the assignment, or would you rather I just hold on to it and deliver it to you tomorrow? You guys cool if I hold on to it till tomorrow? Sorry that took so long.
That way. Yeah, I'm scared, Amy.